mouth is. Tobias is going to tell us what happened when he did just that. Let's welcome him with a heartfelt round of applause.
Thank you very much for the kind introduction. So today, or tonight, I want to tell you a little story. I was part of a project in 2016, and today I want to show you some takes on vulnerability disclosure and also how to do security research for medical device products. Some of you might have seen this kind of news articles. They were out in 2017. You might be thinking, why is this guy talking about stuff happened in 2017? There are such things called NDAs, and mine was for 3 years, so it started to 16, now we have to 19. That's why I'm talking today about this stuff. Story is, there were some pacemakers out there with a lot of vulnerabilities, and it led to a recall of more than 500,000 pacemakers, and also a new way for vulnerability disclosure was taken. So why do I tell you about this stuff? So let me first introduce me briefly to you. My name is Tobias. I work as security researcher, and mainly I do IoT, embedded systems, security, and one of my main area of interest is reversing wireless communication. And back in 2015, I did a talk at Black Hat, focusing on Zigbee security, and some guys from a company called Medzec were watching this talk and said, okay, we also have a interesting project concerning reverse engineering wireless communication. Maybe hire this guy. So this company was called Medzec. Yeah, they are interested in medical device security, and they had a project with the goal to find zero-day vulnerabilities in pacemaker communication. And they assessed 4 vendors, and I was part of the team doing reverse engineering for the St. Jude's project. Yeah. So, quick introduction. Yeah, how does the ecosystem of modern pacemakers look like? So you have a pacemaker that's implanted. Yeah, medical term is implanted cardiac device, an ICD. That's connected to either a programmer. That's usually at the hospital or at the doctor. So you can do calibrations, reading the health data out of the system and send it back to the cloud, the Merlin net in this case, because there is always a cloud, also in medical nowadays. They also have a home monitor that's used for, I think, some comfort for the customers, because usually they had to go to the doctor's office regularly to have the stuff inspected, if it works, what are the data, and just to have it double-checked by the doctor. Nowadays, the stuff is collected automatically using wireless communication, so you just have it in your home, usually in the bedroom, and as soon as you're within the range of the system, your data is collected and sent back to the cloud. That's kind of a predictive maintenance for humans. And it's quite a big step for patients. But that's also a first attack vector, because in the past, this was done by near-field communication, so you had to be really, really close by to get a connection to the pacemaker. But they switched it up. It's now a different frequency band. It's called the mix band for medical devices. It's 401 to 406 megahertz. And we chose this as a first attack vector and said, okay, it would be cool to shock a pacemaker using wireless. So that's easy nowadays, because hardware made a huge progress the last years. Yesterday there was a very interesting talk about the limitations of software-defined radio. Yeah, I can highly recommend to watch this talk, because a lot of the stuff I have experienced by myself, especially the limitation side. So have a look at it. Okay, so we used software-defined radio to inspect the mixed band to find first attack vector. So how do you do this? Because you don't have any information where to start. So first we do wireless reverse engineering, and I want you just to give you a short introduction. What's my best practice for doing this? Not for the pacemaker, but in general, I would strongly recommend to check something called the FCC ID. Every product sold in the US has to be checked by the FCC, and you get a label with a number, and you can connect this number to wrong direction to some information, because there is online a database where you find some stuff from the testing procedure. And if you're lucky, sometimes you just have one device, and you don't want to open it because maybe you damage it, but you want to get to know of the internals. And if you're lucky, you will find on this website also stuff like internal photos, the block diagram, user manual. So that's a very good first start to investigate a wireless device. Also, I can recommend check patents. Google has a patent search online. You won't find the most detailed information, but sometimes you find specifics of protocols. So how does this communication work in general? Also a nice point to check. And of course, product documentation. Our F-chip specs, firmware, software, whatever you get, have a look at it. Take this information. It will speed up your process of reverse engineering drastically. If everything doesn't work, fall back to visual signal inspection. Yeah, but it's a very hard task, and you have to be kind of experienced to do it. And yeah, I would not recommend to start with this. Okay. Also, frequency bands for legal issues. Radio spectrum is very wide. So where to start? For medical devices, obviously, have a start at the mixed band, because it's just reserved for this as a start. And what we also did was interviews. Interviews is always good. Ask people, they have experience with this tooling, what are the problems. Sometimes they can't tell you how it works, but they have experience in troubleshooting. Maybe they say, okay, if we have a lot of Wi-Fi networks, for example, our stuff did not work. So you can think, maybe there is a problem with some interference from Wi-Fi, and it doesn't work. We also used an additional service. The company bought the service that hooks you up with former employees of companies. So we got access to former developers. They worked there. We talked with them, what they think the problems are on a security perspective, where to start. Sometimes they gave us good hints where to have a look at, but I will touch it later on. Okay, Google patent, as I told, that's an example from Zigbee, but you see there is a description how the basic networking works. Also, RF chip documentation, what would I check? By the way, that's not the transceiver chip from the pacemaker, but that's a good example. For example, it's listed what kind of modulations are supported and what frequency ranges are supported, and also what data rates. Legal issues, so the radio spectrum is highly regulated. If you have a look for something that you think is not at the ISM bands, have a look here. Maybe it has also a dedicated, some dedicated space. We did the stuff, gathered some information, did some basic testing. We started with simple replay attacks, so we just recorded communication and played it back to the ICD. And what happened was we nearly instantly found first vulnerabilities. What kind of vulnerabilities? First, we called it crash attack. Yeah, it was no attack; they just crashed. If you replayed a communication for some time, the pacemakers they just crashed and they didn't recover. So you were not able to use them again. There was no fail-safe, no safety, no security mode. They were just broken. Yeah. So we bricked devices just by simple replaying stuff. It was, now is still the major concern I have, because that's no real, advanced attack. It's just this might happen by accident. And we also found a way to deplete the energy very, very fast. that's a problem because you have limited energy, so you can't reload the battery. So if your battery is out, you need to have a surgery and you have to have it replaced. So this means, yeah, also very, very bad. We released some videos, or we, the company called Medzec, released videos online about this. They're still on there. I put some the references on there if you wanted to see it, the proofs, how this works. Funny side story, there is one comment on there, because the videos are not have a very great production quality, and I like the comment. Yeah, I think it's kind of funny. And yeah. So replay attacks, first vulnerabilities identified. But then we dug a little bit deeper and did some real reverse engineering. So we got our hands on the basic packet structure. We found out, okay, where does it start, where's the synchronization, which CSC they're using, what do they do for error correction, but we still struggled with the data blocks. Yeah. In RF, there are a lot of ways to cover up your stuff. Yeah, you can do data whitening, you can do encryption. It was not possible for us to find it easily. So we kind of got stuck because reverse engineering is often a very time-consuming task. And since they had nearly only external researchers, it's also a very expensive task. If you buy like 10 guys looking at pacemakers, we are not the cheapest. I think it costs you a lot of money. And also, even if it's weak cryptography, you won't be able to break it with your eyes. Just looking at it won't solve the problem. So we had a decision to make. Yeah? Get somebody who is good at crypto analysis, or look at a different attack vector. We got for the second. Because there is a lot of other things to attack. There is also a complex IoT ecosystem, and you don't need to attack the hardest target, because everyone is speaking the same protocol. This means we switched it up and said, okay, the pacemaker and the wireless communication directly might be too hard for us to break it in time. Let's have a look at the home monitor. Why at the home monitor? Because it also communicates wirelessly with the pacemaker, and it's a very cheap device. So you can just buy it on eBay for $18. You can get it at home. I brought one today with me, just to show you how good they are made. And we said, okay, maybe there is some stuff on there that helps us understand the protocol. So we took it apart and checked, what our F chips are in there, how they're working, and this took us, a little further down the road. But a big breakthrough was we found some debug ports. They are not protected, so it's UART. Just hook up and you're connected to the system. And the bootloader is not very good protected. Yeah, you see maybe on the screenshot, if you are capable of some basic stuff, it's easy to get root access there. Let me show you. Pray to the demo gods that everything works. So I hooked up a bus pirate that's connected to my system, and it's also connected to the pacemaker monitor I have. You see, now I'm stuck at the login, so there was the traditional boot sequence. What I now do is I just press the reset button. And you see, some stuff is happening, and I just need to press one button to escape to the bootloader. During the screen, you just see it's blob is used, and we just have to wait for the reboot. I press the button. So now we jump directly into the bootloader, and you will see there is written auto boot in progress. Press any key to stop. So that's easy. Help. What should we do? Just type in help. You see what commands you have. There is one called boot. Boot is very promising. Boot Linux in RAM with optional kernel options. Sounds promising because maybe our goal is to directly boot into the shell. But how to do this? Just type in status. You see your kernel command line arguments there. You just copy them. Let me do this. That's a very hard task. Boot. Just insert it again and add just one additional argument. And now we should boot up directly into the, we don't have a login prompt anymore, so we have root access now on the system. And there is some interesting information also out there. Typing is always the hardest part. For example, you see known hosts, where is it communicating to? You see the addresses from the Merlin.net, from the cloud, listed there. What else do you need in a cloud? You need a password, how to log in. Let me check. And there is, for example, one FTP password listed here. And it's not a very good one. I think there is some room for improvement. And this password is the same for every monitor. Just some examples you find very easily. So that's not very sophisticated hacking, but it did the job. So we were able to extract some components from the firmware and go further down the road of reverse engineering the protocol. And what else do we now have? We also have now control over a system that has the proper RF chip for communicating directly with the pacemaker. So the problem also mentioned yesterday is when you do software-defined radio, you have some timing constraints because there is some, like in every protocol, you have some time slots, you need to reply in a specific time. And when you do this with software-defined radio, you have them attached by USB. USB has a very high latency. So sometimes you're just too slow to answer them in the right time to get accepted by the receiver. So we just then switched to the Merlin at home as a tag device. Okay, what else to attack? Programmer. We also bought this. You can buy it on eBay. We bought one recently from a German second-hand medical device reseller for 160 euros with valid medical data still on there. So I think the whole industry need to step up their game when it comes to privacy and cybersecurity, just as an example. So if you tear down this system, there's a removable hard drive. No encryption, like Austin Powers says. They like to live dangerously. One of my favorite movie quotes. So this was our final piece in the puzzle. Why? Because there were Java files, so you just decompile them, have a look, and there is the whole protocol was just written there for us just to implement. And not only the protocol, also some codes they are using for kind of a backdoor access to circumvent encryption. That's not only to blame them, because for pacemakers you have also like other requirements. If you go to Australia and have a heart attack, I think you want that the doctors in Australia are also able to connect to your pacemaker and read some data. So they have kind of a backdoor universal key for making this possible. Okay. So we used now the Merlin at home as an attack device. So we were able to deliver emergency shocks, reconfigure the device, make it vibrate. Test shocks, the demo videos are still on there, on Vimeo. The link is in there, have a look. I think they're better than the ones before. So they had a proper speaker. I think they're really good to just get what we are doing there. Okay, let's play a simple game. Blaming the vendor. Which message authentication code is used? A, B, C, D, or E? So who is for A? A, B, C, close race, D, no D, no E, E, no trust in the vendor. It's actually C, so they're doing a little bit of authentication, but 24-bit RSA. What else did they do? Did they do the homebrewed crypto? You know, I told you about the universal key. Use 32-bit RSA public keys or truncate keys because of memory. C, yeah. They did all of this, yeah. And because you would be able to guess, because when they use 24-bit encryption and then they have 32-bit keys, so they truncated because they didn't have the memory. It's like a first project to do at university or at school, how to do cryptography and do it the bad way. And that's a sad part in it, because we have some IP camps, some Chinese IP camps in our office, just to get to get trained in the stuff. They have the same security level as medical devices. So I think that's kind of a sad part. So let's give you a short technical summary. So we were able to find in 2 months a lot of critical vulnerabilities with potential lethal impact. So everybody, unauthorized users, could remotely just disable your pacemaker, make them vibrate, deliver you a shock. We found a lot of security nightmares in there. Yeah, no best practice was followed. I think that's very bad. But one might think, what about security certifications? Because medical is for certain a highly regulated area. Yeah? And you see there is a logo. It's ISO 27001 certified. And they're very proud of it, because they're the first medical network that is properly certified for information systems management, information security management systems. And they express it openly. They're very good at it, and that's a very stringent worldwide information security standard. But it's not. Yeah, it has nothing to do with product security. Yeah, that's maybe how they run their mail server, maybe, but not how they do pacemakers. Just keep this in mind. Yeah, this certification. It's not for product security. Okay, but what was special? Yeah, because that's just a project with a lot of security vulnerabilities. That's no magic done. You've seen it's not the best hacking you need for the stuff. Vulnerability disclosure, and that's actually, I think, why I'm here today. And the next day is to talk to you about what's a good way of vulnerability disclosure. Okay, what was special? The guys, they hired me, and I thought we do the traditional way. Yeah, we do some research, go to big conferences, talk to a big crowd, and everybody will come to us and buy the services we sell. They did it differently. They licensed the research to an investment company, and the investment company took a short position in St. Jude Medical and bought shares from competitors. This means they published a report with all the findings in there, not the technical details, but with the findings in there, and explained how these kind of findings will affect the stock market price of St. Jude. So, vulnerability disclosure process, no. There was no notification to the vendor previously, because there is a history attached to this vendor. Yeah. This vendor was accused the same vulnerabilities by a guy called Barnaby Jack a couple of years ago, but they were never made public because Barnaby Jack died. So the research in this area kind of got stuck. And so they said, St. Jude, they keep denying this stuff, and it would be just some litigation. Let's just partner with Muddy Waters, because they are good at making these bad vendors pay for the harm they do. It's like a kind of a Robin Hood story. They want to sell you. And as mentioned, this had a very big impact because on the day the information was released, the stock market dropped 12%, which means $2 billion. Yeah, 2 Milliarden. It's a very big number. And I think it's the first time this was done for vulnerability disclosure and for monetizing vulnerabilities, and I think a quite big one. And then it all started, yeah, because St. Jude started to deny the stuff. They said, okay, these researchers, they just want to make money out of us. The results are false, they are made up, that's everything not true. Let's sue them. And they sued a lot of the persons involved, like Muddy Waters, the CEO, the doctors that were involved in this project. And in October, because the report was published in August, and in October we had a third party, independent third party, to just recheck what the work we did. And it was an expert team from Bishop Fox, a US-based cybersecurity company, and they verified every claim we made. So we were ready to go and said, okay, we didn't made it up. Somebody has to take actions. And a couple of months later, the ICS CERT released a vulnerability node, and also the FDA released a vulnerability node together with a first update for cybersecurity. And St. Jude, they said, yeah, we are proud of our security, we are leading the way. But that's not true, because the update was just for communication between the Merlin and the cloud, because this was done unencrypted in the past, and they just put certificates on there. So that's not the update we wanted to happen, because the pacemaker communication, the wireless communication, was still unpatched. Also, fun stuff, because there is in German a nice phrasing for tödliche Schocks. Yeah? You see, Abgabe unangemessener Stimulationsimpulse is the proper word, the medical term for I will kill you with the shock. Yeah. Yeah. So everything is a kind of phrasing. Yeah. A little bit later down the road, the FDA also reviewed the information, and they made an official statement. So okay, they said, that's true. What they're claiming, that's possible. St. Jude, you need to do a second update. Yeah? And they did. Nearly 1 year later, the final update came out, which also targeted the insecure communication. I never retested the stuff, but I think there were a lot of knowledgeable people involved, so this might be good. And we are back at the beginning. It ended in a big recall with more than 500,000 pacemakers. So I think that's kind of an interesting way. But vulnerability disclosure, yeah, we have now the way we just push it out and make the vendor pay. But funny stuff is that nearly at the same time, two other researchers from America, Billy Rice and Jonathan Butts from Whitescope, they're also into medical device security, and they reviewed pacemakers from another vendor called Medtronic. So they did a security assessment, and they also found a lot of bugs and vulnerabilities in there, especially in the ecosystem. So they were able to deploy their own firmware, I think, on the pacemakers, using the software delivery system of Medtronic. They disclosed it to the vendor and tried to work with the vendor to fix it. And you have a new vendor response. So they reviewed it because they have an internal vulnerability disclosure process, but they found this is no new potential safety risk. So it's no problem if you are able to deploy a firmware on a large scale to the pacemakers. That's no problem for them. Has nothing to do with safety. And that's what very often in this position, when you're a security researcher, talk to vendors, they're not used to talk to security researchers, and they try to downplay the findings. They don't talk to you. They will come up with a lot of stories just to don't fix the vulnerabilities. And one of the guys, I think Jonathan Butt said, for the time they just talked about the bugs with Medtronic. They could easily just fix it. Yeah? It's just a question of they won't admit they made a failure, because this would affect maybe the new regulations, maybe the payment from the CEO, I don't know. But it's very, very frustrating also for them, because 2 years later, the vulnerabilities were still in there, and there was no patch out. So they were in the situation still discussing with the vendor. So this leads me to the point, what is the better way? Because that's the traditional way, and I think the more ethical way in the broad perception. When you go to the first approach, you have 1 year later, you have an update. Sounds not the traditional ethical way, but a very effective way to do it. So what is the better way? I don't know. First, in this project, I was pretty pissed because I wasn't expecting this way of vulnerability disclosure. And then lawsuits started, so it was not the best time. But now I think more open about the way they took. Maybe this was a good approach. I'm not sure, and I'm open to discuss afterwards. Give me your thoughts on this in the Q&A. Let's sum it up. Key takeaways. So the first point, in medical or in general safety and security, if it's not secure, it's not safe. Keep this in mind. There is no safety without security. And security is not ISO 27001 certified. That's not equal I am secure, especially not if it comes to product security. There are some new regulations out there. You need to do now cybersecurity risk assessments if you build a new security product. We are working with vendors doing this stuff, but I think there is a lot of room for improvement still. Problems they have, lots of potential new attack vectors. It's like you have a pacemaker, a programmer, a cloud, maybe there are some apps in the future, maybe there is a lot of interconnected stuff. So it's getting more complex also for medical devices. So you need to cover every potential attack vector. Also the cheap end user devices. Maybe they are the weakest point and the way into the ecosystem. Also, this way was a new way of monetizing vulnerabilities. It was the first time, and with a big hit, especially on the media, in the American media. And it started a huge discussion about ethics and vulnerability disclosure again. It's like, I think in InfoSec, every couple of years there's a discussion about how to do proper vulnerability disclosure. And I think there is no one way. It depends. The answer from a consultant. Okay, then one last thing. Why this picture? Because it's my favorite picture in information security. Let me explain. This picture symbolizes my experience in the project. Because first you start, you have a look at it up front, you think, okay, seems properly secured. There might be a way to climb above and do some stuff, but it's a hard way, and maybe they have done a good job. But if you switch your perspectives and take a different angle, one step to the side, and to stay with this picture, it gets much easier. So you have to really cover every angle of your product. Don't go down the rabbit holes in security research. Try to take a step back, get a new look on your problem, and maybe there is an easier way just right next to the way you're in. So don't think because you invested 20 days of research on this protocol, maybe there's a second protocol also built in, that's much easier to do. Okay, so that's my journey. That's the story I wanted to share with you. I hope you enjoyed it. If you have some questions, please ask them now. And I will be also around afterwards and the next days to talk about this. Thank you very much.
Thank you so much, Tobias. So we have microphone angels over there. Maybe. Yes, he's waving his hand. We have a microphone angel over there. And we have questions from the internet, perhaps? No questions from the internet. Internet, step up your game. So, over here.
Just about the legal situation, first question, they just sued for defamation, libel, something like this, like you were lying, but isn't there also an aspect of manipulating the stock market?
That's the point, yeah. They claimed, because due to this false information, they manipulated the stock market, yeah. I'm no expert in the law stuff, especially not in the American ones, but long story short, that's not insider trading. Yeah, that's what everybody usually asks, because there is no inside information taken. It's a proper way to just have a look at the books of a company, to do your own research and do an evaluation and say, okay, we think this company has no outlook on the market, we bet against their stock.
Okay, another question from this side.
Thank you. You didn't discuss the role of the FDA, and in my experience also in cardiology, we had a lot of outdated amplifiers because they had a certification, and they will still be used even though we could build better ones. And I think this is one of the places where this also plays, is that they had a system that was allowed on the market, and it is an enormous investment to re-certify it with the FDA, and I think that's the reason why they took a shortcut. And I think it's, unless this whole system with the FDA changes, it's unavoidable that this kind of products keep on the market.
All right, so the impact of the certification process.
Yeah, that's a very, very good point, and I'm completely with you. But I think there is movement, yeah, they acknowledged that's a problem, and they will need to do a different kind of different process, how to get updates out, how to get security updates out. Yeah, you need to do some kind of separation between safety related systems and other systems, but they're on it, yeah. But I think now it's still very like the old system, but they're at least thinking about it, and I know from some very well-known and popular security experts, they are talking to them, giving them input how to come up with a better solution.
Hi, great story. I don't know if my question is too easy or too hard, because I'm not really in the sector or anything, but I was wondering, when the zero-day exploit was disclosed publicly, if somebody would have, maybe in the next week, used it to cause real harm to a patient, how is it likely that the company would have tried to sue you?
Okay, good question. But I think that's an easy one to answer, because that's maybe my fault. We didn't release proof of concept code. We just said, okay, there is a vulnerability. Have a look at this video. This video proves that there is a vulnerability in there. We never put out the real code to make it happen. But to elaborate on this, what is the potential, the worst impact you can generate? To kill someone. But there are other ways to kill people. And you don't need to do pacemaker hacking, you just shoot them, or strangle them, or run them over by a car. If you're not a politically exposed person, I think that's maybe not your the major concern of getting killed by a random hacker. Yeah, if you have other problems, but for especially exposed persons, this might be a way, yeah.
Do we have any questions from the internet now? Still internet. Come on. I see a question over here.
Okay. You said they had to cut 36-bit RSA down to 24 because of the low power hardware. So how do you think they were able to fix it with this hardware and build a proper algorithm?
Yeah, that's why I always mention it. I didn't retest it, and I had a look at a lot of the code, and I'm curious by myself. But I think they needed. I think there is still a way in there how to get kind of a backup access. I think they just changed codes and protected them a little bit better. But if you have the same hardware, you have the same hardware. Yeah, you can't just do a different register size and switch from to a different key length. I think that's not possible. But I think maybe they did some compensative measures in there. Yeah.
Our very popular microphone angel over here has yet another customer.
Yes. You were talking about the US legal system, I assume. I just want to add that if you were working in Europe or especially in Germany, you would have problems with the Urheberrecht, which is like copyright law, when reverse engineering. There was a great talk on the last Congress about two researcher groups from Berlin and Munich running into difficulties in there, being sued on the basis of copyright. So be careful around there.
I have to follow up on this. The law changed this year, so it's better now for researchers. But what I wanted to ask, yeah, great thanks to the U. What I wanted to ask, did you look at the CPU? So what hardware is inside these things? Is it really so low power, or what is it?
They have custom chips. But it's... I can't remember the specific processor, but I can look it up if you want. Yeah, but they did a custom solution for the stuff. Yeah.
Could it be that our lonely microphone angel has found, yes, a question?
Just a very short question. So how much money did Muddy Waters make out of this?
I'm still curious by myself. Yeah, there are no numbers out. I just know that I didn't get paid for all of my work, yeah, because as soon as they got sued, they froze all accounts, and they set it up long term because the company was founded in St. Kitts and Nevis. That's an island in the Caribbean Sea, not even in the US. And they once explained me by a beer, they had every lawyer on this island, so they can't be sued by a lawyer from this island. So they had a plan in mind already. But I don't know how much money they made. I think their plan didn't work out as they wanted it because the stock market, the stock price recovered as well. But I think it was a huge outburst of curiosity at the beginning because dropping by 2 billions, and there was a merger ongoing. St. Jude was bought by Abbott. So I think that was not the best time frame to get hit by such a market drop.
I see. All right, we have time for one more. Is it going to come from the internet?
Hi, internet.
Oh, all right. Anyone else? No? Then please, another great, warm, heartfelt round of applause for Tobias.
Thank you very much.